Hey guys, and in this video I'm going to talk to you about inferential testing in psychology. Now, I'm just going to give you a really general introduction to what it is. So, what is this video? Why am I doing these videos? Some of you might say, this is a tech channel, what the hell is this video doing on here? Well, as most of you know, I'm a psychology student, and last year when I was studying for my A-levels, now a university student, but when I was studying my A-levels, I did a quick video on each of the topics to help me learn and maybe give you some interesting insight as well. So that's what I'm doing here. My exams are coming up soon, so this video, if I have to explain it to you, I think I'll learn better. So this video is both to help me learn and might be interesting to you, particularly if you're a psychology student. And a lot of people find this, even though it's just the basic stuff, statistics really, a lot of people find this a difficult concept. So maybe if you are an introductory statistics student, maybe this will help you to understand. So the goal of psychology really and science is to constantly move the conversation along, constantly find out new things and particularly test new ideas. So particularly in psychology, you can't just stick someone in an fMRI machine really and see what happens. You have to know what you're looking for before you go and see. You have to create a hypothesis, and this is what you're going to test. So I might say I think people that have higher IQs are more likely to get a job than people with low IQs. So I've got two groups of people, and that's my prediction essentially. So that's what I want to go out and test. So I might get some government data, look at people who have got jobs and people who haven't got jobs, and look at some kind of intelligence measure on those individuals. So what I want to do is look at the probability essentially that my prediction is correct, because in psychology and really in any science there are so many variables that you can never say an argument is entirely proved or an argument is entirely disproved. That's kind of the antithesis of scientific inquiry, and we don't really want to be doing that, but we do want to add support to arguments or maybe help to refute some arguments. So when we talk in psychology or any science, we always talk in probability. So what we're trying to do is find the probability that more, in this case, more intelligent people do better on the job market. But the first snag is we're not actually going to look at you'd think we'd look at the probability that our prediction is true, but the thing is, in science we err on the side of caution. We'd rather disprove an argument than prove it, because it's generally easier to prove something than it is to falsify something. So you're just being more responsible if you go and prove it. So all statistical testing is done from the assumption that there's no difference between groups, and that's called the null or nothing hypothesis. So in this case, our null hypothesis would be that there is no difference between people who are very intelligent and people who are not intelligent in their success of the job market. And that might not be what we're predicting, but that's what we're testing. So we're actually instead of looking for a high chance that that's true, which is what a lot of people first assume and what would be the intuitive thing, we're not testing our prediction. Remember, we're testing chances of predictor, and then if we find that chance isn't a predictor, we can then go on to say that our prediction is supported by the data. So we're looking for the probability that our prediction is true. Well, we're looking for the probability that our prediction is not true. Well, what's an acceptable level? Well, the convention in psychology is to say if there's a 5% or less chance that our prediction isn't true, then that's fine. We'll accept a 5% chance that we might be wrong, and that's called the alpha level, often captured as p less than 0.05. The probability of less than 5% that our null hypothesis is true, because remember, whenever we conduct a statistical test to get a p-value, which I'll talk about in later videos, it always gives us the probability that our null hypothesis is true. It doesn't assume that our experimental hypothesis is true and test that. It assumes that our null hypothesis is true. Well, let's say, for example, that we use an alpha level, a probability acceptance of 5%, and then there actually wasn't a difference between groups on intelligence, but so we were in that 5% tape where we were wrong. Well, that'd be called a type 1 error, and the opposite of that would be called a type 2 error. So that's essentially the general theory between inferential hypothesis testing. I'm going to get into specifically how we would do that in the future, because there are several different tests that you can do which give you p-values in different ways, but the ultimate aim is to get a p-value to find out, okay, what is the likelihood that my prediction is wrong, essentially. What is the likelihood that there is no difference between groups? And the reason why I want to say that there's no difference between groups is just because it's a tradition in science to err on the side of caution, not presume that our prediction is true, to presume that our prediction is false, because when you think about it, with the number of predictions that have been made in the past, it's more likely that a prediction is going to be false than true. So yeah, that's null hypothesis significance testing in a nutshell. I'll be doing more statistical videos in the future, things like the t-test and the z-test, and like levels of measurement and standard error and things like that. But that's sort of an introduction to the basic idea of why we do inferential null hypothesis testing, significance testing. Anyway guys, thanks for watching this video. If you liked it, please give it a thumbs up, share it on Google+, post any comments you've got down below. Anyway guys, thanks for watching this video, and I'll see you in the next one. Bye bye.